It seems that these videos will never end, but it was never my intent to make the first one, much less this third one. But I need to go back over the theme a little bit to see how we got to this point. The initial video was for just a few friends. It was how far a bunch of guys my age can start enjoying their old models again. I had a favorite old airframe. I wanted to update it. I took the old motor out. I put a brushless in. And the first video was basically how do you go about updating an old airframe that flies good and you'd like to enjoy it some more. The second video involved now that the motor's in, how long we want the batteries to last, what batteries, what electronic speed controller do we need, what prop will work best on it. That was the second video. It ended with the right prop. Everything was fine. It was flying really, really good, and I was pleased. This video came about because there was something I did that kept worrying me. I wanted the airplane to fly as good as it can fly. It's a sailplane. So to make it fly properly and to put the CG in the right place, I had to put 6.5 ounces of lead in it, and I didn't like that. That's just extra wing loading. So what I want to talk about in this video is that little bit of extra optimization that we can do. It's flying fine. Very good. I know it can fly better. How do I know it can fly better? Well, I'll tell you. First off, we need to do is know where the CG is with the wings on it, and that's where the CG is. It balances. Next thing you want to know is where does the fuselage balance after you take the wing off. Often it's further back here someplace. The reason you want to know where the fuselage balances, and when you know you should mark it, is because nothing is going to go on with the wings that's going to change your weight that much. But you're going to do a lot of things in the fuselage. You may want to change a different battery pack. You may want to go to a different speed controller. Maybe move servos around. Maybe go to digital servos. Maybe a little stronger servos. Or go to smaller servos. There's lots of things we do in here. And it's real hassle, as you know, that you wonder if this should go here. If I shove it back there, what will happen? And you put the wings back on. You kept checking the CG. Take the wings off, work on it. Put the wings on. Well, if you'll see where the balance of the fuselage is without the wings, then you don't need to keep putting the wings back on. You just make whatever changes you want and see where the CG is and keep moving the CG back to the proper fuselage CG. Now, as I told you before, this airplane had a lot of volume in here because I used to load it up with lots of batteries for an event called All Up, Last Down. That was a fun event, but it is an event that has outlived its application since you can grow old and die on one charge of the big lithium polymer packs now. So that event kind of went away. But I wanted to fly the airplane. That's where all this started. So it happens because of this volume and everything that the CG for the fuselage is very close. Okay, very close to. I'm going to mark it. It's right there. Very close to what it was without. I'm going to mark it on the top here. Okay. Now, we know that no matter what we do to this fuselage, as long as it balances right there, when we put the wing on, it's going to balance right here. Now let's get to the crux of the matter. I know it can fly better because, well, I'll show you. In the process of getting the CG in the correct place, after the new motor and all these things going on, I had to add a chunk of 6.5 ounces of lead. That's a lot of weight to increase the wing loading of a sailplane that should kind of have lower wing loading. So as long as I'm carrying this in the nose, maybe unnecessarily, then the model is not flying as good as it can. Just basic aerodynamics. So now let's play like I have enough wit about me to get rid of that piece of lead. Now I said before that we want to know where the fuselage balances. It balanced right there. Now where does it balance? Well, it doesn't balance there anymore. It doesn't balance where the wing was anymore because of that lead. You can see why I put the lead in it. So we keep going back, well, maybe a little more than that. I kind of like to have the nose down a little bit. That's a little too much. So I'm going to say right there, and I'm going to mark that place. I know what I'm going to do. I'll make this CG, okay? We'll remember that's the wing, and that's where the fuselage balanced with the lead, where it balances without the lead. So how can we fly this airplane with that much out of balance? Well, there's several ways we can do this. Okay, that's 2 inches. Alright, that means that if I want it to balance here, which is where it should, that means that tail is too long or too heavy. Okay, let's just cut 2 inches off the tail. Let me tell you why I don't want to cut that much off the tail. For years, I flew and designed sailplanes with a very short slot. Let me explain this slot business. If you take the wing and just see how many widths of the wing it is from the trailing edge to the leading edge of the stabilizer. That's a slot. And in this case, it's, as you saw, it's about 3 times the wing width. This means that you don't measure it in inches because it would be different for every airplane. But if you consider it the ratio of the division of the wing width chord, then that makes sense. What happens about this slot? I flew sailplanes in competition that had about 2. So my stabilizer is right along here, and this made it very sensitive in pitch. If I got in some rising air, the airplane would get upset and tell me what it was doing. And when I built this, I wanted a stable airplane. I wanted it to lob along through the air with all of the battery power, and in the end, be the last one to land. So I don't want to shorten that very much. The other consideration is, you see this taper? If I cut 2 inches out, this is going to be a different size going here. There's a little taper there. That's a little bit of a mess too. So we take this dimension and cut out the nose. I'm sorry, extend the nose. Well, in this case, we would cut here and add this much in here. Well, this is pretty much parallel. That's parallel right there. So this would be the place to cut it and add the nose. Little work, but it will serve. Now, what we've decided for the most part is that yes, we can see the CG of where the fuselage is supposed to be, where it is now without the weight in the nose. So what is this telling us? Well, we can move the CG with the weight out of it, moving this forward that far, cutting this much off the back. I don't want to do that. This is a little work. Now, let's all remember that many of us have bought the little balsa rubber band airplanes that comes in a little plastic sack, and you get ready to fly them, they crash into the ground or something. What we had to do is take that little, generally it was red plastic, that had the wings plugged into it, and take it and scoot the wing back on the rubber band saddle, on the fuselage saddle. That would put the CG in the right place. We can do that here. Let's see how we can do that. Now, we know we need to move that much. Add it or take it away. Or we could move the wing trailing edge back this far. That will put the CG where we want it. I hope that you viewers are clever enough to know this is wrong. If we want to move it this far, we can add that much. We can take this much out. But we don't scoot this back that far, because when we scoot this back, we're shortening the tail, but adding the nose. No, we don't want to move it 2 inches. We really only want to move it 1 inch. Okay? That will accomplish the same thing. That'll shorten this an inch, add an inch here, 2 inches. Now, let's see how we're going to do that. I bet we can do it. Now we can see that we're going to not need this bulkhead, because it was to hold this in. The lead we're getting rid of. So we're going to get rid of this. The hole in this bulkhead will clear that battery. That's good. When we take this out, this battery is going to slide even further forward. That's going to help our CG problem and the amount that we need to slide the wing. So we're going to take this out, move the necessary things forward, and then see where the fuselage balances with our new configuration. So let's do some chopping, but not on the fuselage. Okay, now that worked out okay. I hogged out that big fat bulkhead that was right here that held the lead in between the two of them. It had been a lot easier to do if I didn't build so well, but I finally got it all broken out and everything. So now the battery is as far forward as it can comfortably go. The ESC is connected up. There's the battery cables, but I also found my little 4-cell pack that I'm running the receiver on, and moved it forward. I may get rid of it later once I get comfortable with that my ESC is that reliable. I don't like to run new ESCs as a total power source to my electronics, like the receiver and the servos, until I get a little confidence in them. So I fly this little extra a nickel metal hydride pack. So I got that forward. So now what we can do is we can put the lovely canopy on, and we'll see where it balances now. Now that we've done the bulkhead tearing out, sliding everything forward that we can, this is the configuration of the fuselage that we should expect to be flying. What have we gained? Well, we know that eventually this fuselage should balance right here. It does, and it's tail heavy. Before we removed all that most recent stuff, it should balance there. Nose heavy. Now, as it presently is, it balances there. That is perfect. Now, I mentioned my little altitude limiter. That's what this is. I can show you, that's not much there in the airplane, but I can show you better with this one here. I have several. They're not that expensive. Now, this one is made by Sky Limit. These are nice people. They respond to your phone calls and emails. They're model flyer oriented. Now, what this does is plugs into your receiver. This plugs into your ESC. This plugs into the programmer. This is the programmer. I only have one because they all seem to work the same. I can select and step through the various functions here, and the only thing I want to do is set the altitude at which the motor to the power to the motor turns off. There are almost no way that you can compare improvements in model designs without something like this. I've done quite a bit of work here. I didn't show any of the interim steps because it just looked like a bunch of hacked up balsa. We've all seen hacked up balsa. It never looks pretty. The end results are several. First, I moved the trailing edge stock, that's the stop of the wings, back. How far? I'll talk about that in a second. This peg used to be here. We checked the CG of the wings relative to the fuselage, and I wanted to move that back by the same amount I measured from the CG with and without this lead chunk, which was, remember, that's what we really set out to get rid of. Now, I said that we need to move it back this far. So all we got to do is move the wing back this far. And I said, no, that's not right, obviously, because while we're moving the wing back, we're shortening the tail and lengthening the nose. Well, yes, but there is a ratio between the CG and the nose, CG and the tail. That occurred to me pretty quickly. And I thought I'd go ahead and do the math because that'd be kind of fun. I like doing math with little levers and weights and things. And then I had this other thought. No, don't do that. Put the wing up here, put the rubber bands on the wing, and slide that wing back and forth to get the CG where you want it. This is what I was saying a little earlier about when we had the little balsa airplanes. We'd plug the wings in a little piece of plastic and slide the plastic back and forth on the fuselage. Well, those little wings, those little airplanes had fuselages about that long. Well, we've outgrown those. But aerodynamics, journey doesn't change. We may change, the stuff may change, but it doesn't change. So I slid the wing back and forth, got the CG where I thought it ought to be, glued down the trailing edge, and now I can butt the wing against this, and the CG will be in the right place without this. And that's really what we set out to do to start with. Now that we have the wings on it, I'll show you about this sliding back the wing business. You can imagine kind of what I had when I had my 12-foot sailplanes in here. That's the back edge. Whoop. There we go. That's the back edge of the leading edge front spar. Back edge of the front spar. It's balancing. That is perfectly fine. And you see how far back I put the wings. Now, it is intuitively obvious I got a problem here. It used to be kind of like that. I don't know what I'm going to do about that now. I'll do something. I'm sure it'll be brilliant. But I'll do something. But you see, while I was doing this, I was moving some things around here in the shop, and I found some 116-inch sailplane wings that used to fly real good. I ought to have wit enough to put those 116-inch wings on this sailplane fuselage. It'd be a different sailplane then, fuselage, in place of these 86-inch wings. Now, have I ever told you about why these wings are 86 inches long? That's a strange number, isn't it? They used to be 100-inch long. These are some very old Frank Zayek 100-inch original Olympic 99 wings. They had 2-piece and a steel rod. I flew them in competition a long time ago. In a hard wind, I launched, and as people said, I usually, on a launch, went for broke. Well, in this case, as it turned out, it did. The wing broke at the edge of the sheeting, and I had to recover a bunch of pieces. I liked the wing, so I cut the center section out, butted together what was left of this 100-inch wing, and that's where this 86 wing came from. And I have flown this thing a whole bunch. I still enjoy this airfoil. Now, in the process of me finding this 160-inch wing, the thought occurred to me, I've said several times, this is a long fuselage, and I said why it was. There's no reason I can't put a 116-inch wing on this fuselage, and I will, but not right now. We started out to make this airplane fly better. We've done that. We went through what would be called compromise. That's where this came from. Then we kind of went through a little period of optimization. Your sailplane should fly as good as they can. This is start to approach perfection. You may be a horrible flyer, but your sailplane ought to fly as good as it can. I'm talking about now pretty much perfection. Not in me, but in this. I think I've gotten there. Well, we're ready to give this thing a flight with the wing all the way back. And I said I was going to extend the canopy, and I wanted to keep my little clip in there, which works so good. So this has worked out fine. So let's see if this thing is going to fly. Okay. The test flying yesterday morning was interesting. I learned some things. The ascent angle was about what I expected. The ascent rate was higher than I expected, but I did take 6.5 ounces of lead out of the thing, so that shouldn't have been that big a surprise. What I was most surprised at is how slow that airplane will fly. I was concerned when I was realizing that I wasn't using as much elevator as I expected, but I was using a whole lot of rudder that didn't seem to have a lot of effect sometimes. So this meant that the moment of the rudder, of the tail that I changed from here to here, that shouldn't have made that much difference. So if I'd had elevator and rudder control, I'd been more concerned. As it was, I just had a rudder control problem, just not enough rudder. So that indicates it's not a moment problem. It's just a matter of area when I'm flying so much slower than I used to fly. Now, my flying buddy Craig did the videography, but he was also out testing his Ollie 2. He got the kit from Skybench. I saw the kit before he started working on it. I was really impressed with the workmanship, the selection of balsa, the plans. It is a really nice kit. Craig built it very well, and it flew really, really good. So in the process of testing his Ollie 2 from Skybench, he kept pulling back on the stick, and I kept waiting for it to stall. Wingtip stall? Nope. Straight ahead stall? Nope. It would just get high angle of attack, drop the nose, and mush a little bit, and it was back to its flying speed. I don't think it ever stalled. A stall is basically when the nose drops below its normal flying angle. If it just drops back to its normal flying angle, that's a mush. If it drops down below that angle, that's a stall. And I was curious how long it'd take that Ollie 2 to recover from a stall. No way to find out. Basically, it just wouldn't. So my hat's off to Skybench. That's a good model. Now what I need to do with my good model, I need to increase the rudder throw, and I have a good way of doing that. So let's see how I'm going to do that. This ought to be easy enough to do. I've got 2 holes there that I can drop that horn to. So the best thing to do, I think, is just to pull that screw, pull this, twist this out, and just move it. I'll move it down 1 notch and see how much I've got. Right now I have that much and that much. That's a pretty good amount of area, and that's a good amount of throw for the way it was flying before, but that isn't much throw for the low speed I'm flying now. So I'll just need to increase that throw a little bit. I've gone down 1 hole on the control horn. I've got another hole to go. When I go to 116-inch wings on this thing instead of the 86, I might need to go to that hole. But as it is, that looks like sufficient control for the low speed flying that it's doing now. And I'm sure that will work out just fine. I've enjoyed doing this video for you. I hope you've learned something. And remember, if you're flying electric sailplanes, pointing it straight up is not the best way to get to altitude. Often you need to slant it just a little bit, get good airflow over the wings so you can appreciate the lift from the wings. You may end up with more altitude than you would pointing straight up in the same amount of time. We know that electric indoor models can hang on their props. Well, they can hang on their props at 6 feet and run the batteries down. That isn't necessarily going up just because you're pointing up. So enjoy your electric sailplane flying, and make them fly just as good as they can.